Okay?
So whenever the x is on the bottom, that means backwards?
Yes. Well, if you're taking the derivative, you can't use the rule unless x is on the top. So yes. Okay, so look at all these examples. What do you notice about your boundaries on these? That's not an x, it's a 6x. That's not an x, it's a 9x squared. Instead of an x, that's a 2x. Okay, here it's a 2x and 2x. Okay, so what we're going to cover today is the chain rule. It's extremely similar. It's not very hard. You're going to be able to do it fine. So, at the top, we're going to take the derivative d dx of the integral, but instead of being from a to x, it's going to be from a to u. Now, let's make a quick little note here that a is still a constant, but u is an expression of x. Oops, you can't see that. Okay, so instead of u being a constant, u is standing for like x stuff, okay? So when I take the derivative, what's the antiderivative of little f? Big F, and I do capital F of u minus capital F of a, right? So I find the antiderivative, I plug in the endpoints, then I subtract. Okay, from here, I still have the derivative in front. When I take the derivative of f, capital F, what do I get? I'm back at little f, right? Now, here's the caveat though, I have to use chain rule. So it's going to be normal f of u, but then times u prime. Okay, and this comes from the fact that when you take a derivative, you have to do chain rule. Now, quick question on the f of a. If a is a constant, when I take the derivative of that, it's just going to be 0. So, minus 0. So, let's write our rule over here to the side. This is the chain rule. It would be the derivative d dx from a to u of f of t dt equals f of u times u prime. Okay? Again though, this is not super hard. You just have to learn it in case they give you one where it's not an x. So look at number 1. I'm taking the derivative from a constant to 6x. Well, then I'm going to plug in 6x. So what will secant t be now? Now it'll be secant 6x, right? Because I'm keeping the f the same. I'm just changing what's plugged inside it. And then what do I have to times by? What's just times by 6. So you're just taking the derivative of what that endpoint was. Because remember, that's where u is the endpoint. Okay, look at number 2 right next to it. I'm going to plug in my 9x squared. So it'd be the square root of 4 times 9x squared. But then I have to multiply by the derivative in the front. What's the derivative of 9x squared? 18x. Okay, look at number 3. Can I use my fundamental theorem on that one right now? No, because it's backwards. So I'm going to have to reverse it. d dx integral 8 to 2x of negative 4 cosine 3t dt. And then remember that once I reverse it, I'm allowed to take this upper boundary. I'm going to plug it in where my t is. And then I'm going to multiply by its derivative at the back. So I'm going to have negative 4 cosine. And then it was a 3t. I'm plugging in a 2x. What's going to be in the middle there? 6x. Good. I am going to do that in the next step. Okay, and then I have to times by, what's the derivative of the endpoint? 2. Okay, then from there I'd get negative 8 cosine 6x. Make sense? Okay, there is, actually let's do number 4 and then the second number 4, and then we'll come back to that one. Okay, so look at number 4 right here. I want you to find capital F of 2. So capital F of 2 is going to be the integral. Look at your equation right here. Starting at 1, and then it was going till 2x. If I plug in 2 to 2x, what's my new upper bound now? It's going to be a 4. Good. And then 6 t minus 1 squared dt. Okay, how are you going to do that antiderivative? U sub. Good. So my u is going to be t minus 1. What's du then? Derivative of t is just 1 dt, which means that dt is du over 1, but we don't really care, right? So let's rewrite it. It's going to be 6u squared du over 1, which you don't have to put. And then what else do you have to remember to do on u sub? Yep, your endpoints have to change. So remember, the way that you get the new endpoints is you plug the old endpoints into what your u is. So if I used to have a 4 on top, what's 4 minus 1 now? 3. And then I used to have a 1 on bottom, well then 1 minus 1 is 0. What's the antiderivative of 6u squared? Not derivative, antiderivative. U cubed, but then you have to divide 3 with 6. So 2. So remember, you want to add 1 first and then divide by that. Okay? And then we're going to plug in 3 and 0 and then subtract. Remember that when you have endpoints, you don't have to put a plus c because they're going to cancel each other out. Okay, capital F of 3 would be 2 times 3 cubed, which is 27. And then F of 0 is just going to be 0. Then I subtract those, I get 54 minus 0, which is just 54. Okay, and we're going to try to start incorporating lots of different parts of questions just since our test is coming up. Okay, F prime. Now they want me to take the derivative. What do I do when I need to take the derivative of 1 to 2x 6t minus 1 squared dt? What do I do? You just learned this. Plug the 2x in and then times by what? Times by 2 in the front. Very good. So remember, this is my u. So I'm going to sub my u in 6 2x minus 1 squared, but then I have to times by 2. Now I'm putting my times 2 here in the front, but it's the same thing. Okay? So really, that's going to be 12 2x minus 1 squared. So far, so good? Because of the derivative up here, if this is my u, was a 2x, then I have to times by 2. And so I just wrote it in the front instead of in the back. So I could combine it with the 6. Okay, then from there we're finding f prime of 2. Well, that would be 12 times 2 minus 1 squared. And that's good enough for the AP test, so it's good enough for us. Okay, go down to the next part. Now I want the derivative again. I now want f double prime. Okay, for these types of problems, if you did chain rule once, you're going to have to do chain rule again. So look at your original expression right here. When I take the derivative of that, I'll label it f double prime here. I'm going to multiply the 2 down. What's my coefficient now? Then I have to take away 1. So if it was squared, now it's to the 1. But then you have to times by the derivative of the middle. So I'm going to end up with another times 2. And if you took the third derivative, you'd have to times by a 2 again. So if you start with the chain rule, every time you take the derivative, you're going to be redoing that. Okay, so this is really a 48 2x minus 1. Got it? Okay, then if I want f double prime at 1, I would have 48 times 2 times 1 minus 1. Okay, and that's good enough. Okay, before we get to the FRQs in your packet, I want you to do a little bit of your homework if you haven't already. So, you just have one. We'll come back to that one. Thank you for reminding me though. So get out your homework. I'm going to pick like 2 of them maybe for you to do. Okay, do number 4. And do number 7. 4, 7, 4, 7. Okay. And this is the homework from Monday. This is your only homework this week. Anybody need it?
Which ones are there? 4?
4 and then 7.
I'm gonna get it.
Now, if you're squaring the whole 2x, then you have two choices. You could put parentheses around it, around the 2x squared, or you could put 4x squared. But since you're plugging in the 2x, you have to think about it. It's 2x times 2x. Does that make sense? So 4 and 7.
All of 7?
Yeah, do all of 7.
So
You need to put parentheses though around the 2x if you're plugging in the whole 2x. Yep. Times 2. Good.
that's it.
Yep.
What if we don't put those parentheses?
Huh?
What if we don't put those parentheses?
If you wanted to, what I'm going to do is when I square 2x, I'm going to just make it a 4x squared. So that I don't have to put extra parentheses. Huh? Yeah, so you're going to take the circle of 2x, you're going to plug it in where the t is, then you're going to have to times by the derivative of 2x in the front as a chain. Yep, that's good. What did I put? 4x. You're taking the derivative of the endpoint. So if it's a 2x, the derivative would just be 2. Derivative of 2x is just a 2.
I thought we...
Not the derivative of the middle, the derivative of the endpoint. Here. Okay. It is, except your parentheses aren't. So if you're plugging in 2x for t, you need to have parentheses around your 2x. And Jesus, I think you might have not put them too.
Yeah, but I need to put...
No, that's good. You added them. Yes?
So,
We did. Perfect. Good job. Okay, I want you to check your number 4 and see if you did it correctly. There are 2 ways for you to write this. So I'm plugging in 2x here. So you could have written it like this. Sine of 2x squared times 2. That would have been fine. Or you could have written it like this. What is 2x squared? 4x squared times 2. What you could not have done is taken these middle parentheses off, because if you only put 2x squared, that means the 2 is not squared. That's wrong. So you would want to make sure either group it and do 2x quantity squared, or go ahead and just square it. 2x times 2x is 4x squared. Okay, go down to number 7, please. Okay, we're just going to run through parts. I guess we'll just do all of it. Okay, so f prime, you want the derivative. Notice that your equation has an integral in it. That's how you know that you're doing second fundamental theorem. So I'm going to plug my 2x in. What am I going to get for part A?
Would we choose 2 plus 4?
No. Remember that when you take the derivative, it cancels out with the integral. So am I actually taking the derivative of sine? No, I'm going to keep it I'm going to keep it a sine. Okay, because remember, you're not actually taking the derivative because the integral is there to cancel out with it. So it's going to stay sine, but then instead of a 2t, it's a 2 times 2x, which is really a 4x. Then what do I times by in the front? What's the derivative of my endpoint? Times 2. Okay? Then in part B, we want f prime of pi eighths. Well, that would be 2 times the sine of 4 times pi eighths. Okay, well think about 4 pi eighths. Which reference angle is that when you reduce it? That's really pi halves. So then really I want the sine of pi halves, which is what? It is 1. So overall it would come out to be 2, because it's 2 times 1. Okay, part C, you're doing chain rule. Remember, if it was a chain rule originally, it's still going to be a chain rule. So look at your f prime. We want now f double prime. So if it was a 2 sine 4x, what's the derivative of sine? Cosine 4x, but then what do I have to times by in the front? Well, I already have this 2, but what's the derivative in the middle? 4x, so it'd be an 8. Make sense? Okay, because there was already a 2, and I'm timesing by the derivative of 4x. That's where the 8 comes from. Okay, then for part D, I want f double prime of 0. Well, that'd be 8 times cosine 4 times 0. 4 times 0 is 0. What's the cosine of 0? 1. So it'd be 8 times 1, which is 8. Got it? Okay, while your homework's out, turn the page. Circle part F. We're going to do this one tomorrow. Okay, that one's kind of a curveball. Like 6 people have asked me about it. So we'll do part F in class tomorrow. The rest of it you should be able to do. Okay, go back to your notes. Yes, ma'am. Okay, so there's one other thing we really have to get to today for you to be able to do your homework. Like 10 minutes. We should be fine. Okay, so look at part A. We want g of 1, g prime of 1, g double prime of 1. Look at your g of x. What is the boundary? A 2x. That's how you know when you take the derivative, this is going to be a chain rule.
You gotta do number 4. It's on the homework.
Ah, crap. You're right. Look at you. So on it. Okay, I forgot to do this one with y'all. This one. Okay, number 4, if you want to mark it on your homework, this is going to be like numbers 5 and 6. Okay? So, I'm going to put like number 5 and 6 on the homework. Okay, now, look at the question. Why does it not fit the same format as all the other ones that we've done? What's wrong with it? It has 2 U's. It has a U on top and a U on bottom. So we're going to use this rule. Okay, I can split this up into the integral from 0 to 2x of 5 over 3 plus t squared dt minus the integral from 0 to 5x dt. Now, I'm going to draw you a little tiny picture just to show you. This should make sense when you see it. Let's say I wanted to integrate from 3 to 7. Okay, just, you don't have to draw this, just watch. Okay, let's say here's my function. Let's say here's 3, here's 7. I only want the integral between 3 and 7, yeah? So that would be here. Would that be the same as if I integrated from 0 to 7, but then I minused back out the integral from 0 to 3? Would that come out to be the same? Yes, you can always use that property. This is the only place where it really comes in useful. So if I integrated 0 to 7 and then I minused off 0 to 3, that's the same. Now, why is this better? Well, now this is going to fit my formula that I need to use second fundamental theorem. So for this first one, what am I plugging in? 2x. What am I going to times by in the front? 2. On this one, what am I going to plug in? 5x, but what am I going to times by in the front? A 5. So your answer is going to be this. I'll write it over here to the side. Okay, it's going to be 5 over 3 plus 2x squared times 2 minus. And then in the second fraction, I'm plugging in a 5x as my special u substitute. But then I'm going to have to times by 5. And that would be your answer. Okay. So maybe let's do one of those off your homework. Let's do number 6. Okay, so split it up first. You want the integral from 2x to x squared, but that doesn't fit my property. So instead, I'm going to split that up to be 0 to x squared ln t dt. Yep. That's you. So I want the integral from 0 to x squared minus from 0 to 2x. And then from there, you're going to pop those endpoints in, then multiply by the derivative. That's your chain rule piece. So for this first one, I'm going to plug in x squared. My second one, I'm plugging in 2x. So what would my answer be for the first part? Natural log of x squared times what in the front? 2x minus. Second one would be what? ln of 2x and then times 2. Very good. Now, actually, I want to fix something. Okay, be really careful with the way that I wrote this. What's wrong with my line right here? What should it have in the front? What was I taking? The derivative. Okay, so remember that you only use that rule if you're taking the derivative of the integral, not if it's just an integral. And I may have done that on the notes as well, so I'm going to go back and fix that. Make sure that when you split that integral up, you should still have a d dx in the front. Okay, so yep, right here. Okay, when you split those up, you need to keep that d dx in the front. Okay, we're not going to have time to do that FRQ that I wanted to do, but flip over to the back and just do part A. Okay, this will be good review. So you have an f of x, you have a g of x, super straightforward. All they ask you to find is f prime and g prime. Okay, looking at that first one, easy points here. We're using second fundamental theorem. What do I do when I take the derivative of the integral? Take the 3x and plug it in, then times by what? Times by 3. So I'd have 4 plus 3x squared, and then times by, what's the derivative of that endpoint? The endpoint here. 3. Okay, I did something wrong. What did I do wrong? Gotta put those parentheses, otherwise it's wrong. Okay, it's not just a x that's being squared, it's the whole 3x. Your other option would be to square it and put in 9x squared. Okay? Alright, what about this one? Do it. You should be doing chain rule. What's the derivative of f on the outside? F prime of sine x. And then what's the derivative of sine x for me to times by at the end? Cosine x. Good. Okay, so both of those are chain rules. One of them you're doing just normal chain rule, the other one's chain rule of second fundamental theorem. Okay, good job. We'll finish that packet tomorrow.